In this video, we will take a look at exception handling in C++ using try and catch blocks. Exception handling or error handling is a very common thing to do in your application. This is where you suspect to get an error, so what you will do is you will catch it before it breaks the application. Because when you have errors in the application, well, what the application will do is that it will throw an error on the console. As a developer, you can catch these errors to avoid breaking your code. So let's say in front of you, you have a function called divide, which accepts a and b as parameters. And what it wants to do is that it wants to display a divided by b. Now, this right here could result in an error. Well, maybe we got a equal to 12, but b equal to 0, so the denominator is 0. This will result in a division by 0 error. What we could do is we could catch this error, or we could handle this. So what I'm going to do here is instead, I'm going to put it inside an if block. I'm going to say if b, which is the denominator, if it is equal to 0, that I want to do something. Otherwise, if it's not equal to 0, I just want to see out the division, so everything works properly here. But if the denominator is 0, then that means we might get an error. So I want to handle this error. What I will do here is I want to throw something. I want to throw an exception. And in order to throw an exception, we need to include a header file called exception. This header file exception right here has all the exceptions you might have during your code. And one of the basic and most general exception is called exception, right here. So this right here is an exception constructor, okay? And what I'm doing right here is that I am throwing an exception. So if this if statement is true, what I will do is I will throw this exception. Now, when you throw exceptions in your code, what you need to do here is that you need to handle them. You cannot just throw exceptions like this, because when you throw an exception, your code will break. To avoid breaking your code, you need to handle these exceptions. So what you will do is you need something called try and catch. So let's say inside the main, I call my divide function and pass it 12 and 0. Now, if I run my code, definitely I should get an error because I am throwing an exception. So I'll say I'll compile my file. So as you can see, my program terminated because there was an exception that was thrown. So as you can see here, we tossed an exception. What I need to do here is that I will wrap this divide function inside a try and catch block. So I'll write try and catch like this. Inside my catch block, I will say divide. So what I'm doing here is that I am saying to the compiler, try this expression, because I'm putting it inside a try block, and whatever is put inside the try block, it will be tested or tried. So I'm saying to the compiler, try this expression, and if it results in an error or an exception, or if it throws an exception, I want you to catch it. But what is the type of the exception we need to catch? Because the catch block here must catch or handle or receive an exception. So because here we're throwing an exception, I'm going to pass an exception object. So I'll say exception and I'll call the exception E, like this. Now, what could I do once I catch the exception? Well, for example, I'm going to print it. So I'm going to say CEER, which this one is similar to cout, but it's used in the context of exceptions and errors. So I will display simply E.what. And this function what comes from the exception class. The what function displays the message. So I'm going to say E.what and I'll say end L. Now let's test our code. As you can see, my program didn't break, and let me prove it to you. So when I catch this one right here, I could say cout hello world like this, and I could just continue normally. I could say also here cout hello world again, for example, and my code will continue. So let's go ahead and see. As you can see, everything works properly. Now I forgot to put a new line right here, but we get the idea. My code didn't broke, or it wasn't broken. Because why? I handled the error using try and catch, and I could continue my program, or the flow of my program could continue normally. However, if I didn't catch the error like this, so let me put it outside the catch block, and I will put nothing here. So outside the catch block, if I didn't handle the error or the exception thrown, what will happen? My program will terminate, and the flow of the program will not continue. That is why it's important to catch your errors in order for the flow of the program to continue normally. Now the cool thing about exceptions or the exception class is that it is a base class of other exceptions. So from this class you could derive other multiple classes, and we will see a few right here. We could derive from the exception class a error or a exception called runtime error. And this runtime error, we could use it to create our own sort of exceptions or errors. To be more specific, we could create our own custom errors by simply inheriting other exception classes. So, what I want to do here is that I want to create a class called divide by zero error. And this divide by zero error, so first of all let me write it, divide by zero error. What this class will do is that it will inherit from a class called runtime error. So I'll say runtime error. Now this runtime error itself, it actually inherits from the exception class. So this one right here is a derived class of this exception class, which is the base class of all errors. So what I could do right now is that I could go ahead and first of all create the constructor of the divide by zero function, or excuse me, class. And after this, we always need to, first of all, in the concept of inheritance, we need to always call the constructor of the base class. And in our case, the base class of this class is runtime error. So what I'll say is runtime error like this, and I'll call the constructor. But the thing is about this is that with the constructor of the runtime error, I could pass a message or a custom message for myself. Like I could say, can't divide by zero. Like this. And so this right here is a custom message, and when I use the what function right here, this message will appear. Let me show you. So just a recap, what we did right here is we created our own exception called division by zero error, which inherits from the runtime error. What we did here is that we need to first of all initialize the constructor of this class, and because it inherits from runtime error, we actually we called the constructor of the runtime error and we gave it a custom message. Now, instead of throwing an exception right here, I'm going to throw a divide by zero error exception or error. So I'm calling the constructor of the divide by zero error. Now what I will do is let me delete all of this and let's create a new catch block. So I'll say catch like this, and what I'm going to do here, instead of accepting a exception object, I'm going to accept a divide by zero error object like this, and I'll call it E for example. Now what I could do with this is that I want to simply print the message, so I'll say E.what. Now because this class divide by zero error inherits from runtime error, and the runtime error class has a what function, that means the divide by zero error will also inherit the what function. That's why I am able to use it. Now what do you think the what function will display? Well, let's go ahead and see. So I'm going to compile my file and then I will launch it. As you can see, can't divide by zero. This was our custom message that we gave the runtime error constructor. So this is about division by zero error. Let's go to another one, and it's going to be out of range error. Now, for example, I'm going to delete all of this, and let's say you had an array of integers, for example, and you have 1, 2 inside of it. Very simple array. Now I'm going to create a const size right here variable which stores the size of the array, and you'll see why. So I could go ahead and say size right here, so I could specify the size of the array. Now let's say you have a function called void get element by index, and I will pass the index of the element. So what I'm going to do here is that if I go ahead and say cout, or first of all I need to also pass the array like this, so array, and the size of the array like this. You'll see why. So of course we need the array. Now instead of saying cout like this and say arr index like this, well, maybe the user gave us index 5 for example, and we know our array only has 2 elements. This will result in an error, so we need to handle this error. What I could do here is I could do the following. I could store it inside an if. So I could say if index greater than or equal to size. Why equal? Because index should always be less than the size by -1. And so if the index is greater than or equal to the size of the array, what I want to do is I want to throw an error. Otherwise, what I want to do is display the index of the array, or excuse me, I want to fetch the element at this index. Now, in order to throw an error that resembles this situation, I want to go up here and I want to create a class called index out of range. So index out of range like this. So this class, I want it to inherit from a class called out of range like this. And again, this out of range class right here is actually a class that inherits from the exception class, the base class. And right now what I'm doing is that this class right here is the derived class of this class because it inherits from this class. Now, what I want to do here is that I want to say private and I want to pass an index data member. Now I'm going to say public, and inside the index out of range constructor, I want to pass the index that resulted in an out of range, and what I want to do is that I want to assign it to my data member. Now again, because we are in the context of inheritance, we should always call the constructor of the base class, so out of range like this. And what I could do right now is that I could give a message. I could say the index, and I want to specify what was the index. Now, in order to concatenate a index, or excuse me, a integer with string or with a string, what I need to do is, first of all, I'm going to include a library called string like this. And what I want to do is I want to convert to string the integer index by using the toString function that belongs to the header file string. Now, with this one completed, I want to say that the following index resulted in a out of range error like this, range error. And I forgot the plus operator right here in order to concatenate these strings together. Now, this is my class, and let's go ahead and test that out. So right here, I'm going to say throw and index out of range. And because this constructor accepts a data member or a value to its data member, I'm going to pass the index right here. Now, let's go ahead and test it out. I'm going to go ahead and create a try block or try catch block. And what I'm going to do is I'm going to try the following function. So get element by index, and I will pass the index, for example, 5. Now, we know that this will result in an error, so I will catch the exception. And I need to pass also right here the array and the size of the array like this. Okay, now I will catch the index out of range exception that we just created. I'll call it E. And what I'm going to do is I'm going to simply say E.what. And again, the out of range class, the base class right here of this derived class actually has the what function, so that's why the index out of range here class could inherit this function. So what I'm going to do is I'm going to display our message. Let's go ahead and test it out. As you can see, the index 5 resulted in an out of range error. So what we did is we successfully handled this specific error by creating a specific class for it. Now I want to explain a concept called stack unwinding. And in order to explain it, let us use this example. As you can see, we have 3 functions, function 1, 2, and 3. The third function actually throws an exception. Now, in the main, we are trying the function 1, and we are trying to catch the exception that must be thrown by function 3. Now, as you can see, each function right here calls the other function, and in function 2 we call function 3, so we will arrive to function 3 and it will throw an exception. But what do you think will happen here? Now, if I go ahead and run my code, let's go ahead and try it out. As you can see, the exception was catched, and these are the functions that were called. Now, what exactly happened right here? So what happened in this example is that you can see that the function 3 throws an error, right? When this error is thrown, the program goes into a state of shock. And now the compiler will be searching for a specific, or excuse me, will be searching for a nearest catch block or try and catch block. Why? Because it needs to handle this exception. Now, because there isn't any near catch blocks right here, what will the stack do is that it will unwind or go back to where it started. So, what will happen is that it will go back to function 2. And because function 2 doesn't have anything, it will go back to function 1. And because it doesn't have any try blocks, it will go back to the main. Now, because the main actually has a try and catch block, that is good for the compiler. What will happen is that the catch block or the try and catch block right here will catch the exception and do what they need to do. And this is it for exception handling in C++. And this is it for exception handling in C++. Thank you for watching today's video. Make sure to subscribe to stay up to date for the next video, so I hope to see you in the next one.